Okay, proof for the expectation. So just to remind you, expectation of x is the sum from, I've put a k in here because we're already using r. So from k equals r to infinity of k times the probability x equals k. So when you're on your, in fact, you could put an x in there if you want. I think we've been using lowercase x a bit more, haven't we? So if you think about it, you'd have x, probability x equals x. The smallest value x can take is r, and then r plus 1, r plus 2. It's an infinite probability distribution. And then you'd have a probability that x equals r. So maybe change that one to an x as well. Probability x equals r plus 1, probability x equals r plus 2, etc. And then you times and add your way through. So that's all I've done there. So I've written that out. So that's your expectation of x. And then the probability that x equals r, we found these on this proof here, just to remind you. So the probability x equals r is p to the r, and I want to times that by r. So I get r p to the power r. Probability x equals r plus 1 is r p to the r q. So you end up with r p to the r q times r plus 1. So just written that slightly neater. And then the next one along, I'm doing the probability x equals r plus 2, which is r plus 1 over 2 factorial p to the r q squared. And I want to times that by r plus 2 as well. So you get r plus 1, r plus 2 over 2 factorial p to the r q squared. And again, you could do another term or two just so you're happy with how this sequence progresses past here. If I pull out r p to the r, because I've got that all the way through as a factor, then I end up with 1 plus r plus 1q plus, so I'm taking r p to the r out, which leaves me with r plus 1, r plus 2 over 2 factorial q squared plus. And then if we go back to that lesson starter again, I've actually got this one here. And so the stuff in the brackets is equal to 1 minus q to the minus r plus 1. So r p to the r, lots of 1 minus q. So again, we're using this formula for binomial expansion with a negative power, hence the negative binomial expansion. 1 minus q is p, so I've got r p to the r times 1 over p to the power of r plus 1, and p to the r over p to the r plus 1 will give me 1 over p. So this all goes down to r over p. So the expectation of x is equal to r over p. And the proof for the variance is similar. You need to find the expectation of x squared, and you'll find that you use 1 minus q to the minus r plus 2 in that proof. But I'll leave that with you if you fancy having a go at it. And next video, I'll give an example using the expectation and I'll give you the formula for the variance as well. So expectation of x, R over P.